Hello, family. Welcome to another session of Maths Fanatics 24/7. In this question, we're going to be looking at quadratic number pattern given herein. Okay, so without wasting time, let's get straight to it. Okay, so they say the pattern X, Y, 11 forms a quadratic number pattern, right? Quadratic number pattern. Okay, before I even start solving the question, when I hear the word quadratic, what comes to my mind is second constant difference. The second difference must be the same. Okay, awesome. That's the idea I have now in my mind. Perfect. And then they say where X is term number 3. So this is T3. Okay. And then T4 is Y. So this is T4. Then T5 is 11. So this will be T5. So before I even continue reading, I'm going to do this. I know that I have X, I have Y, I have 11. Here I must have T2. Here I must have T1 because they started at T3 here. Do we see it? So I'm going to create spaces for term 2 and term 1, and then I'm going to continue reading. They say the constant difference equals to 2. So I know that when I subtract them, at the end, I'm going to get 2. On the second level of the difference is going to be 2. Right. So before we even proceed, let's just set up this part. Each and every part that we're given, we're going to set up an equation for it. I'm going to set it up here. So I know that I have term 1, I have term 2, I have term 3, I have term 4, I have term 5, right? Then I know here I'm going to subtract term 2 and term 1, T3 minus T2, T4 minus T3, and then T5 minus T4, right? And then here, I'm going to subtract that, that, and that. Perfect. If you remember well, the second difference of quadratic is always 2a, right? Then this number here, the difference here will give you, let me just erase so that we can see it. Okay. So this part here is going to be 3a plus b. Remember? Then this part here is going to be a plus b plus c. Okay, perfect. So this part here, it's term 1, it's a plus b plus c. So I'm done setting up for that. But I know that the answer here is going to be 2, right? Because they said the second difference is 2. Remember, this is D1, which is first difference. This is D2 for second difference. The answer is 2. Okay. And then they say the second term is double the first term. So which means T2 is what? Is equals to 2 times T1. Because they say the second term is double the first. Perfect. So now I can easily do this here. I have T1 here, and then the term 2 will be 2 times T1, right? Because it's double. Awesome. And then the question wants me to solve for X and Y. Okay. Perfect. I'm sure we can do that easily. Let's see. So we're going to do the differences, right? Differences. So here I know that is going to be 2T1 minus T1, which is T1, right? Because here there's 1 basically. It's 1T1. Do you see? And then it's 2 minus 1. So it's going to give us 1T1. I'm sure it makes sense, ladies and gentlemen. Sharp. So the answer here is T1. And then here is going to be X minus 2T1. Here is going to be Y minus X. Then here is going to be 11 minus Y. And then for this part, I can see that if I try to subtract this ones, I can see that it's going to get complex. But I was already given this, right? So here I'll just say 2a, 2a, 2a. And then I know that they said the second difference is 2, right? Then this part we said is 3a plus b, right? Then this part here we said is a plus b plus c. Okay, perfect. So now we can do this. We can start solving it. Okay, perfect. So I'm going to take it from here, right? So 2a equals to 2. Then to solve for it, I'm going to divide both sides by 2. Divide by 2. Then this 2 will cancel that one. Then I'm left with a equals to 1. Right. Perfect. So I know the value of a now. Then I can substitute it here and there, right? For here, I have 3. Where there's a, I'm going to put 1 plus b equals to t1, right? Perfect. Because that is equals to t1, which means 3, because 3 times 1 is 3, plus b equals to t1, right? And then, okay, let me just create the rooms like this. And then for this one, remember a is 1, so I have 1 plus b plus c equals to t1, plus b plus c equals to t1, right? Okay. But there's something amazing that is happening here. If you check here, I have t1. I also have t1 there. You see, so t1 equals to that, and t1 equals to this. So it tells us that this part and that part must be equal because they are both equals to t1. So we're going to equate them. So we're going to say, therefore, 3 plus b equals to 1 plus b plus c. And then this one will come that side. So I have 3 minus 1. This b will cancel with that one. Then I have c. Therefore, c equals to 2. Right. Perfect. So I'm only left with finding b. Okay. So to get the last letter, ladies and gentlemen, it's always the same method. Ne? You are going to take the term whose value is unknown. Ne? In this case, it's term 5, right? So you take the term whose value is known. So we know that term 5 is 11. So you're always going to choose that one to get the last letter. Ne? Awesome. So I know that the general form is Tn equals to an squared plus bn plus c, right? And then I know that T5, which is term 5, is equals to, I'll just substitute my a is what? Is 1. Then the n is 5, because it's the position there. Plus, I don't know what b is, so I'll say b5, and then the n is 5, so I'm going to multiply by 5 there, then plus 2, right? But we know that term 5 is 11, so term 5, I'm going to replace it by 11, equals to 1 times 5 squared gives us 25, plus b times 5 is 5b, plus 2. And I have 11 equals to 27 plus 5b. Then I'm going to have 11 minus 27 equals to 5b. So let's come this side. So what is 11 minus 27? It's negative 16, right? Then 5b. And then we're going to have to divide both sides by 5 so that b can be isolated. Therefore, b equals to negative 16 over 5, right? And then this means that our formula for the nth term is equals to, therefore, Tn equals to an squared plus bn plus c. You see it? But the one, usually they don't show it. They expect you to know that there's an invisible one there. So I advise you to get yourself used to not writing it. Ne? But here I'm just putting it in for practice purpose. Okay. And then, ladies and gents, I'm always going to advise you to check your solution. Ne? I'll show you how I always check if my Tn is correct, right? I just use a calculator, okay? So let's get my calculator. There's my calculator there, right? Awesome. So to check, right, this is a function. You go to mode, then table. Some calculators is 3, I think. So table. And what did I do? Let's check. Mode, in this case, is 7 on mine. Then it's going to show you f of x. So the n, you're going to replace it by x, basically, right? So I have 1 alpha x squared minus 16 over 5. And then in bracket here, I can put x, and then plus 2, right? Awesome. Then you don't need g of x. You're always going to start at 1, right? So I have up to term 5, so I'm going to end at 5 in this case. Does make sense? If you had term 4, you're going to end at 4. Yeah? We're just verifying, remember. Okay, and then step always 1. Always step must be 1. Then we're going to verify if this is correct, right? Let's check. So let me get the different color. Let me get black. Sharp. So ladies and gents, I was told that the second term is double the first term. So if I multiply the first term by 2, I can see that I'm going to get that one, right? Awesome. And then of which verifies that I solved this properly, basically. Does make sense? So any form of verification that you see, it's good. Ne? So term 1 is going to be that, but they wanted us to solve just for x and y. X is term 3 is 1.4. So x equals to 1.4, and then y equals to, let's check what the value of y is, 5.2. Okay. Y is equals to, let's see, 5.2. Right. And then also this further verifies your solution because term 5 is 11 there, right? Then you know that your formula for the nth term is correct. Now we can answer the second question. So guys, before we proceed, here, you're always going to have two unknowns. You have, this is the value, right? Then this is the position. So the hint that I ask you to do is this. Always ask yourself if the given thing is the position or the value, and then substitute it in the right place. So the position, you're going to substitute it here and there, right? Perfect. So now let's check. Find the value of, okay, this one was straightforward. They need the value, right? They give you the position. You see, sometimes they'll give you the value, they'll ask you to find n, which is the position. But in this case, they gave us the position, which is n. So everywhere where I see n, I'm going to replace by this number. So we have Tn. So remember, the n is 201. Because to 1, where there's n, you replace by the 201 minus 16 over 5, 201 plus 2, right? Then I advise you to always just use brackets when you are substituting. Awesome. And then if you press your calculator, this should give you 39759.8, which is the final answer for this question. And that's it, ladies and gentlemen. If you find it really helpful, please share with family and friends so that they can also flourish in this subject and do well. Thank you very much for your time. See you in another session of Maths Fanatics 24/7. Aluta continua. Tanko.